Okay, today we're going to be talking about verifying a trigonometric identity. So this is where you are given a trigonometric equation, and it's kind of like the simplifying. On the left-hand side, what you want to do is you want to simplify the left-hand side of this equation, and you want to get it to equal sine of x times tangent of x. Now, the verifying is where it's giving you this answer, but it's asking you to show how each step that's going to get you to that answer. So I'm going to do it through Alex so that you can see exactly what you're going to be expected to type in and how you're going to do it. In order to do verifying your identity, what you're going to want to have handy is your identity sheet that shows you the reciprocal identities, the quotient identities, Pythagorean, and even and odd. So you're going to want to have this handy because that's what's going to help you verify what they're doing on each step that's getting them, in this case, to the sine of x times tangent of x. So for this first problem, the first part of the left-hand side says 1 minus cosine squared times secant of x. Well, if we can recognize that 1 minus cosine squared, that looks similar to one of our Pythagorean identities. So what we're going to do is we're going to go to our Pythagorean page. Now, I don't see 1 minus cosine squared, but remember that you can rewrite any of these Pythagorean identities to solve for another piece. So going back here, I've got 1 minus cosine squared. If I subtract this cosine squared over to the other side of this first equation, that's going to be equal to sine squared. And so what I can do is I can replace that 1 minus cosine squared of x with a sine squared of x. Now, what rule did I just use? I used a Pythagorean identity. So underneath rule, you're going to go down here and you're going to hit Pythagorean. Now, the next step, right now we've got sine squared of x times secant of x. Well, I know that I can simplify secant of x. If I go back to my formula sheet, secant of x is equal to 1 over the cosine of an angle. So I can replace that then with 1 over cosine. On my sheet, that was one of the reciprocal identities. So here for the rule, I'm going to hit reciprocal. Now next, I still want to continue simplifying. What I have here is I've got 2 sines in my numerator and a cosine in my denominator. Now, nothing can reduce. If I had a sine in my denominator, I might be able to use some algebra and simplify. But what I can do is I can break apart that sine squared into sine of x times sine of x. So I'm going to say that that is an algebra step. The whole point of me doing that is because, remember, I need to get a tangent of x in my answer. Well, tangent I know is sine over cosine. So by breaking apart my sine squared, that will give me 2 sines and I can get that sine over cosine. So now I've got sine of x times sine over cosine, and I can simplify that into tangent of x. If I go to my sheet, sine of x over cosine of x equaling tangent is a quotient identity because we're dividing those 2 trig functions. So right here underneath this rule, I want to hit quotient. So for verifying identities, it's where it's giving you the answer, but you have to justify what you're using for each step to get you along the way. And so when you're done, then you're going to go ahead and press check. And we got it correct. All right, our second problem that we're going to do is, again, verifying, but this time we've got 1 minus cosine of x times 1 plus cosine of x, and we need to transform it into 1 over 1 plus cotangent squared of x. So we're going to go down. The first thing that we can see that we have to do in order to simplify is that we have to get 1 minus cosine squared of x. Well, where are they getting that from? They're getting that because they're multiplying these 2 binomials together. So they're multiplying 1 times 1, which is just giving us the 1. And then they're multiplying 1 times cosine of x, which is just positive cosine of x. Then they're going to multiply negative cosine of x times 1. So those values are going to reduce and go away because we've got our positive cosine of x and our negative cosine of x. So they're going to combine like terms, and that's why we don't see them there in the middle. Then we have to multiply our negative cosine of x times positive cosine of x, and that's where we're going to get negative cosine squared. So how are we getting that step? All we did there, we didn't use any of our trig identities from our sheet. We just did algebra to get to that first step. So we're going to hit algebra. Next thing is that we've got 1 minus cosine squared. I recognize that anytime I've got a cosine squared and a 1, I want to go look at those Pythagorean identities. So 1 minus cosine squared, if I subtract that cosine squared over to the other side, just like I did on the last problem, that's going to leave me with sine squared of x. And so that is going to be the Pythagorean identity that I'm using there to get me to that next step. Now, I need to get a denominator. I'm trying to get 1 plus cotangent squared. So what I'm going to do with my sine squared of x is I'm going to rewrite it as 1 over cosecant squared. So anytime that I have a sine, I can rewrite it as 1 over cosecant. Since I have sine squared, that's going to be 1 over cosecant squared. Even though we don't see the squareds appear in the reciprocal identities, that's still what it's going to be under. So I'm going to use reciprocal. And then I need to end up with 1 plus cotangent squared. Well, cosecant squared, again, if I recognize cosecant and cotangent, those are together in a Pythagorean identity. So anytime I have a cosecant squared, I can replace that with cotangent squared plus 1. And so I'm going to replace that denominator with that 1 plus cotangent squared, and I was using a Pythagorean identity to do that. And so then I'm going to go ahead and hit check and correct.